All right, the important part of this question is looking at the molecular diagram of calcium chloride in water, which is soluble. So if it's soluble, we would expect its ions to split up. So and just kind of be randomly. Just need to make sure there's enough chlorines for each of these. Now, if you wanted to get really fancy, you could diagram the water molecules. So remember, the negative end of water's polarity would be attracted to the calcium. So again, when we say that something is aqueous, this is what we mean, that the ion is surrounded by water molecules. And if we did the same thing for chlorine, the positive end of water would be surrounding the chlorine ion. Okay. When we get to something that is slightly soluble, so calcium hydroxide, that means not all of it has dissolved. So somewhere at the bottom, we would have a solid form of calcium hydroxide. So these would be sitting at the bottom. And you would have some free-floating calcium. And you could do either OH as two ions together, or you could just do OH as a group to keep that polyatomic ion together. But there would be less. Again, there is solid present. So here's where we're looking at more of an equilibrium. So you have some ions that are going to be breaking off the solid and getting into solution. You would have some ions kind of getting attracted to the rest of the solid. So remember, since there's ion charges here, there would be forces of attraction to pull these and form that lattice or network of molecules. So when we write this as an equation, we look at calcium chloride. We're going to see that it breaks into calcium ions and 2 chloride ions. So that's important that you balance these. So if you want to put the phase notations on, you can. AP does not actually require phase notations when you write their equations. Calcium hydroxide would look very similar since you have -1 ions. And then bismuth 3 sulfide would be bismuth plus 3. And remember, bismuth is bivalent, so I'm really undoing my crisscross here. There's going to be 2 bismuth ions because of that subscript, plus 3 sulfide ions in that one. And then the equilibrium expression is like any other equilibrium, is I have to look at what my equation is, and only things that are aqueous or gas are going to show up. Pure liquids and solids do not. So there's not going to be anything on the bottom. So for calcium chloride, you're going to see +2 concentration to the first power, and for the chloride ion, you're going to see that raised to the second power because of the coefficient of 2 in the balanced equation. For bismuth, it's going to be a little more complicated, but I'm going to do the bismuth +3 ion and raising it to its coefficient of 2, and then the sulfide ion would have a coefficient of 3. So again, if you know your rules for writing equilibriums, this KSP, so again, this is solubility product, so that's why this deals with the solubility of solids, is really the same concept. It's just you have no denominator because these are always solids.